recall that what's the name of a graph that looks like this? Positively happy what? Parabola. Quadratic or parabola? Yep. You're all telling me the awesome things. Okay, what makes something a quadratic graph or a parabola? How do we recognise it? We saw it written down. What feature of the function would tell us it was quadratic?
Yeah. X is the highest power of x is 2.
Yes, so we would have an x squared in there. Yes, no x cubes, but x squared is the maximum. Yeah. If it looked like that, ooh. Maybe kind of like that. What do we know about it? Yeah. Yeah, it would be negatively sad. So in other words, it would have a negative x squared or a negative 3x squared or something. Yeah. And what about if I was trying to draw the graph of x squared plus 3? How would I know how to draw that graph? Only one person here remembers anything we did the other day. Leah. Good. So normally we would have our graph crossing here at 0, 0, but this one here would be crossing at 3. Oh, yes, obviously crossing at 3. Yes, we're good? We're good? Okay, we're now going to a different type of graph. Notice where is my 3 this time? It's minus 3, but also where is it? Yeah. Yes, so it's inside a bracket, isn't it? Yes, so before we had an x, not x cubed, an x squared, we could have had that. That graph would have been down here at negative 3, okay? But this graph here has got an x minus 3 and then we're squaring it, okay? First things first, you need to make sure you understand the difference. This one, just x squared, then take away 3. This one, we're taking away 3 and then squaring it, yeah? For graphs like this, they're actually going to shift the graph left or right. So if you see a bracket before you've got your square sign, your parabola is going to shift left or right. So these ones shifted it along the y-axis. These ones are going to be shifted along the x-axis. Now, this is where you have to try and make sure that you are not going the incorrect way. If we have x minus 3, it's actually going to shift it 3 units to the right. And it's actually going to cross here at positive 3. Now that's all connected to the, if you recall, when we had stuff like this, when we had that quadratic equation equal to 0, what were my two solutions of this graph? What did we know about this graph? Where did it cross the x-axis?
Would it be negative 2?
Negative 2 and positive 5. Remember they're the opposites. Okay? If we had this, x minus 3 squared equals 0, we know that means we've got two brackets the same. But the principle is the same thing. It would cross the x-axis at positive 3. And that's why here, it will not cross, it will touch the x-axis at positive 3. So it's going the opposite direction than you might think. Okay? So for graphs like this, it's going the correct way, if you like, as you would imagine. For graphs when they're in brackets, they're going to the opposite direction. Okay? So for this one here, we've got x plus 4 all squared. It's going 4 units to the left, so it's this vertex is now at negative 4. Okay? But you may get a combination of the movements. So we could have a number in a bracket and a number stuck on the end. Okay? That means we just deal with them one at a time. I would suggest probably deal with the things that are closest to the x first. So we can see that because we've got this negative 3 value in here, we're shifting 3 units to the right. But this plus 5 has the same effect, even though it's not just an x squared graph. It's going to shift it 5 units up. Now, if you remember, this point here, okay, so this is actually a minimum point, but this point there on the parabola is called the vertex. So if we use that as a point of reference, where was my vertex for my just straightforward x squared graph? What do I call this coordinate? 0, 0, yes? Also known as the origin. Okay, so our vertex was at 0, 0. Where is my vertex now? If I've moved 3 units right and 5 units up.
3, 5.
Yeah, not 3. It says the coordinate 3, 5. Okay, so if my vertex is at 3, 5, do we think that we would be able to just look at this equation here? Okay, but not expand it, not do anything with it. But would you be able to look at that and tell me where the vertex was? Well, I'm hoping that you could. So I'm hoping, oh, this is the one we've just done, so it was negative 3, 5, so our vertex was at 3, 5. For this next one, the x plus 4 all squared plus 1, where would the vertex be? Shayla, do you think you can tell me? Negative 4, 1. Your work. Gabrielle, how about the next one? 1, 2, negative 3.
So is that like, when you said it will go in the opposite direction?
Yes. As in when it's in the bracket, it's going to go to the right, it's gone to the left. Yeah. Okay? So if you were asked to sketch these graphs, if I was asked to sketch this, and I mean sketch, I could draw a set of axes. I know that my vertex is at negative 4, 1. And I know it's a positively happy because there's no negative sign there. Oh, that was pretty bad. But I could do that, couldn't I? I know that that's what it was going to look like. Yeah? Now, this format should be familiar to you. We did do it. Not difference of 2 squares. Do you remember we did do a few of them? It's the completed square.
Oh, we did like 5 seconds.
We did it for 5 seconds, yeah. We might do it for a few more seconds. So not a load. So if you complete the square for a quadratic expression, it helps you sketch it because you know where the vertex is going to be. You probably still want to find the y-intercept. Let's recap. How do we find the y-intercept? What do we know? What value do we know along this line here? No, it's not going to be negative, not if we've got a parabola that looks like this. Where we've got this line here, what's another name for this line here? We know it's called the y-axis. What's another name for that line? Yeah. Oh, someone's trying to trump you. It's where x equals 0. So if we know that x is 0 along that line, what would we do to find the y-intercept? Substitute 0 into here, yeah? So we would have 0 take away 2. What's that? 0 take away 2. Negative 2. Squaring negative 2 gives us positive 4. Take away 3. 1? What? Oh, bless my little cotton socks. I was doing this one, wasn't I? I was doing that one. I was thinking, something's gone totally wrong there. Secretly, if I was doing this one, we would have 4, 0 plus 4, 4. Squaring it, 16, plus 1, 17. So it's going to come up with 17. Well, that one that freaked me out a little bit. Okay, there's so a whole lot of information pattern there. A little bit too much? Or are we good to go? 10 minutes.